Download this code from codegive.com, link in the description below. Alright, buckle up, because we're diving deep into factory patterns with TypeScript, no BS style. This is going to be a comprehensive, practical guide that'll equip you to confidently wield this powerful design pattern. Forget abstract theory, we're focusing on real-world use cases and clean, understandable code. Disclaimer *: while I can try to mimic the no BS style, I am an AI model, not a human. I will strive for clarity and directness. Also, there are no episodes here, it's just one big comprehensive tutorial. What we'll cover *: 1. What's a factory pattern, the why. 2. Simple factory, the starter. 3. Factory method, the flexible one. 4. Abstract factory, the grand architect. 5. When to use, and not use, factory patterns. 6. Real-world examples and code. 7. Advanced considerations, dependency injection, config. 8. Common pitfalls and how to avoid them. 9. Q&A, anticipating your questions. 1. What's a factory pattern, the why? At its core, a factory pattern provides an interface, or a mechanism, for creating objects without specifying the concrete class of the object you're creating directly. In other words, you delegate the object creation logic to a separate entity, the factory. Why bother? Decoupling your client code, the code that uses the objects, doesn't need to know how the objects are created. This is huge for maintainability. If you change the object creation logic, you only change it in the factory, not all over your code base. Abstraction * you abstract away the object creation complexity. The client code just asks for a thing and gets it, without needing to understand the intricacies of that thing's construction. Flexibility * factories allow you to easily introduce new types of objects without modifying existing client code. This is invaluable for extensibility. Testing * factories make it easier to mock and test object creation. You can mock the factory and return controlled test objects. Code reuse * centralizing object creation in factories promotes code reuse, reducing duplication and improving consistency. 2. Simple factory, the starter. The simple factory, also sometimes called a static factory, is the easiest to grasp. It's essentially a function, or a class with a static method, that takes some input and returns an instance of one of several possible classes based on that input. Code example, simple factory. Explanation ***. Product interface * defines the common interface that all concrete products must implement. This ensures a contract for behavior. Concrete product A and concrete product B ** these are the concrete implementations of the product interface. They represent the different types of products our factory can create. Simple factory. Create product type * this is the factory function. It takes a type parameter, and based on that parameter, it creates and returns an instance of the appropriate product class. Usage * the client code calls simple factory. Create product with the desired type and receives a product object. Notice that the client code doesn't need to know anything about the concrete product A or concrete product B classes directly. Pros of simple factory ***. Simple to implement. Centralizes object creation logic. Cons of simple factory ***. Violates the open/closed principle. If you need to add a new product type, you have to modify the simple factory. Create product function. This can lead to a growing, complex, and difficult to maintain factory. Asterisk not very flexible. 3. Factory method, the flexible one. The factory method pattern addresses the open/closed principle violation of the simple factory. Instead of having a single factory class that knows how to create all types of objects, the factory method pattern delegates the object creation responsibility to subclasses. Code example, factory method. Explanation asterisk. Asterisk product interface asterisk same as before. Asterisk concrete product A and concrete product B asterisk same as before. Asterisk creator, abstract factory. This is the abstract factory class. It defines an abstract factory method that subclasses must implement. It also has a sum operation method that uses the product created by the factory method. This demonstrates that the abstract factory provides a template or blueprint for how products are used after creation. Asterisk concrete creator A and concrete creator B, concrete factories. These are the concrete factory classes. Each one overrides the factory method to create a specific type of product. Concrete creator A creates concrete product A, and concrete creator B creates concrete product B. Asterisk client code asterisk the client code now works with the creator abstract class. It doesn't need to know anything about the specific concrete factories. It just calls creator.sum operation, which in turn calls the appropriate factory method to create the product. Pros of factory method asterisk. Asterisk obeys the open/closed principle. Adding a new product type only requires creating a new concrete product class and a new concrete factory class. You don't need to modify existing code. Asterisk more flexible than simple factory. Asterisk promotes looser coupling. Cons of factory method asterisk. Asterisk more complex than simple factory. Asterisk can lead to a larger number of classes. 4. Abstract factory, the grand architect. The abstract factory pattern takes things a step further. It provides an interface for creating families of related objects, without specifying their concrete classes. Think of it as a factory for factories. When to use abstract factory asterisk. Asterisk you have families of related products that need to be created together. Asterisk you want to ensure that the products created are compatible with each other. Asterisk you want to avoid client code depending on concrete product classes. Code example, abstract factory. Explanation asterisk. Asterisk button and checkbox, abstract products define the abstract interfaces for the products. Asterisk Windows button, Windows checkbox, Mac OS button, Mac OS checkbox, concrete products concrete implementations of the abstract products for different platforms. Asterisk GUI factory, abstract factory defines the interface for creating the product families. Asterisk Windows factory and Mac OS factory, concrete factories concrete implementations of the abstract factory. Each one creates a family of related products for a specific platform, Windows or Mac OS. Asterisk application, client. The client code now depends on the abstract factory interface. It receives a factory instance, example Windows factory or Mac OS factory, and uses it to create the UI elements. The client doesn't need to know the specific concrete classes of the buttons and checkboxes. Pros of abstract factory asterisk. Asterisk creates families of related objects. Asterisk ensures that the created objects are compatible. Asterisk hides the concrete classes from the client. Asterisk very flexible. Cons of abstract factory asterisk. Asterisk the most complex of the factory patterns. Asterisk can lead to a large number of classes. 5. When to use, and not use, factory patterns. Use factory patterns when asterisk. Asterisk you need to decouple object creation from the client code. Asterisk you need to create families of related objects. Asterisk you need to hide the concrete classes from the client. Asterisk you want to provide a consistent way to create objects. Asterisk you want to improve the testability of your code. Asterisk you anticipate needing to add new types of objects in the future. Don't use factory patterns when asterisk. Asterisk object creation is simple and doesn't require any complex logic. Asterisk you don't anticipate needing to add new types of objects in the future. Asterisk the complexity of the factory pattern outweighs the benefits it provides. 6. Real-world examples and code. Let's explore some real-world scenarios where factory patterns shine. Asterisk database connections. Asterisk you could have an abstract factory for creating database connections. Concrete factories could create connections to different database systems, example MySQL, PostgreSQL, MongoDB. Asterisk UI frameworks. Asterisk as shown in the abstract factory example, UI frameworks often use factories to create platform-specific UI elements. Asterisk game development. Asterisk factories can be used to create game entities, example enemies, characters, items. Asterisk document processing. Asterisk factories can create different types of documents, example PDF, Word, text. Example, database connections, simple factory. 7. Advanced considerations, dependency injection, config. Asterisk dependency injection. Div factories are often used in conjunction with dependency injection. Instead of the factory directly creating the concrete objects, it receives dependencies through its constructor or setter methods. This makes the factory more testable and flexible. Asterisk configuration. Asterisk the type of object to create can be determined by a configuration file or environment variable. This allows you to change the behavior of the factory without modifying the code. Example, simple div with simple factory. In this example, the file logger class has a dependency on a file path. The logger factory receives this dependency as part of the config parameter and injects it into the file logger constructor. 8. Common pitfalls and how to avoid them. Asterisk overuse. Asterisk don't use factory patterns for every object creation. Only use them when they provide a clear benefit, decoupling, flexibility, etc. Asterisk complex factories. Asterisk keep your factories simple and focused on object creation. Avoid adding too much logic to them. Asterisk violating the single responsibility principle. Asterisk each factory should be responsible for creating a specific family of objects. Don't try to create too many different types of objects in a single factory. Asterisk tight coupling. Asterisk if your factory depends on too many concrete classes, it can become difficult to maintain. Use interfaces and abstract classes to reduce coupling. Asterisk ignoring error handling. Asterisk always handle potential errors during object creation, example invalid input, missing dependencies. 9. Q&A, anticipating your questions. Asterisk Q, which factory pattern should I use? Asterisk A. Asterisk start with simple factory if your needs are simple and you don't anticipate adding many new types of objects. If you need more flexibility and want to obey the open/closed principle, use factory method. If you need to create families of related objects, use abstract factory. Asterisk Q, how do I test factory patterns? Asterisk A. Asterisk mock the factory and verify that it returns the expected objects. If you're using dependency injection, you can also mock the dependencies that the factory injects into the objects it creates. Asterisk Q, can I combine factory patterns with other design patterns? Absolutely. Factory patterns can be combined with other patterns like builder, prototype, and strategy to create even more powerful and flexible solutions. Q. How do I handle dependencies when creating objects in a factory? Use dependency injection. Pass the dependencies to the factory's constructor or setter methods. Conclusion. Factory patterns are powerful tools for managing object creation complexity and promoting code maintainability and flexibility. By understanding the different types of factory patterns and their strengths and weaknesses, you can choose the right pattern for your specific needs and build more robust and scalable applications. Don't be afraid to experiment and adapt the patterns to fit your unique requirements. And remember, the goal is always to write clean, understandable, and maintainable code. Now go build something awesome.